Hello, this is Mrs. Ward, and I am going to go over the notes for section 5.1, extrema on an interval. So what we are going to do in this section is we are going to understand the definition of extrema of a function on an interval, understand the definition of a relative extrema of a function on an open interval, and find extrema on a closed interval. So first of all, what extrema means is it means like a maximum or a minimum. That would be the extremes, I guess is the best way to put that. So a minimum is going to be the lowest value. So if I'm looking at the graph, it's the lowest point on that interval. So if I want to say that f of c is my minimum, and remember this f of c is the same thing as my y, is a minimum. If f of c is lower than any other f of x, is less than or equal to any other f of x for all x values in an interval. And I'm going to make it a closed interval from A to B. Remember, those brackets mean that it includes the point A, includes the point B. So when I'm looking at the graph, this is like the lowest value. And remember, the minimum is going to be the y value. The x is where it occurs. The maximum, so I'm going to say f of c is the maximum if f of c is greater than or equal to f of x for all x in an interval. And we're going to make this a closed interval again from A to B. Remember, this is going to be the highest value that I see. And again, remember, it's the y value that is the max. So when I have two types of extrema that we're talking about, one is called an absolute and one is called a relative. The absolute means it's the highest if it's the maximum, or the lowest if it's the minimum. Y value overall. In other words, for the entire graph, it is the highest value or the lowest value. That would be an absolute. The relative means that I'm going to be compared to the things, compared to the y values around it. So remember, we drew the picture, and if I think I did something like this in class. So if I'm looking at this, if I ask you for the absolute highest or lowest, you're going to say for the graph like this, there is no absolute max, there is no absolute min, because this will continue going down, this will continue going up. But if I look for a relative and I'm comparing it to what I'm looking around, I would say here, this would be like an absolute max. This might be like a relative max, and this might be a relative min. So looking at what's around it, this would be the highest point that I see around it. And then this here would be like the lowest point that I see around it. So basically, it's telling you when your graph changes directions. Like here, my graph is increasing, increasing, increasing. I hit this relative max in this case, and then my graph starts decreasing. And then here I'm decreasing, 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 hit this relative min, and then I start increasing. So a relative extrema just compares what it's around. So I hope that you understand the difference. So an absolute has to be the highest overall, the entire graph. A relative extrema just says I'm comparing what's around that point, and then I'm saying whether it's a relative max or a relative min. Also, relative would be if I had an interval too. Then I could say that it was a relative max or a relative min. So let's talk about the first one. So if I say that f is a continuous function on the closed interval from A to B, then f has both a minimum and a maximum on that interval. So if I'm telling you that I'm only looking at that function between 2 points, then I most definitely can have a max and I most definitely can have a min. So the graph that they gave us is f of x is equal to x squared minus 3. So we're going to plot that graph, and if you don't, like I know my vertex is at -3. And then if you're not sure how I'm getting these values, you could do an XY chart where your x would be x, so like let's say -2, -1, 0, 1, 2. And then your y values would be when I put in x squared minus 3. So this would be 1, -2, -3, -2, 1. So when I plot those points, 1, and get a graph that looks something like this. Now this is once on the closed interval, and the interval they're giving me is from -2 to +3. So -2 is right here, and +3 is right here, which makes, I'm probably, since it's going to 3, let's do ourselves a favor, and let's go ahead and find 3. So 3 squared is 9, 9 minus 3 is 6. So that graph is going to actually go up to that point there. So now I have that graph. Now, if I want the absolute max on this interval, so on this interval, I'm ignoring this part of the graph. I'm trying to, so patiently. That didn't work. I'm not looking at anything over here, not looking at anything past here. So if I ask you for the absolute max, the highest y value, I'm going to say that highest y value is going to be right here. So the highest y value is going to be 6. And if I ask you for the absolute min, the lowest point this graph is going to get to is going to be this point right here, which is -3. So then the next thing I'm going to ask you, what is the value of the derivative at the relative extrema? So I want to know what the derivative is. So I'm going back up to my equation, which was f of x is equal to x squared minus 3. I'm finding the derivative, so f of x, the derivative would be 2x. And then I want to know what the value is at my extrema. So if I do this, well, if I put in the x value, that's going to be 0. So it's going to be 0. So here's a hint. At your extrema, your derivative will be equal to 0. And the reason why that is if I go and I look at the tangent line, if I go to sketch a tangent line at that point, at that vertex, that's going to be 0. It's going to be a horizontal line. This one, yes, I'm going to have a slope that's not 0, but it's an endpoint, so that's why it's a little bit different. For the next one, it's asking me to find the extrema of f of x. So in the extrema is where the derivative is equal to 0 or the derivative is undefined. There's two places. Derivative is equal to 0, derivative is undefined. So the first thing I'm going to have to do to find my extrema of f of x is I am going to have to find the derivative. So finding the derivative will be 3x squared minus 3. To find that derivative, I want to know when it's going to be equal to 0 or undefined. Well, this is 3x squared minus 3. It's never going to be undefined. There's not going to be a place where this graph is undefined. It's not going to happen. So now I'm going to find where it's equal to 0. I'm going to set this derivative equal to 0. So that's step 1, is setting this derivative equal to 0. And so I'm going to take 3x squared minus 3, set that equal to 0. Add 3 to both sides. 3, divide both sides by 3. X squared is equal to 1. take the square root, and I'm going to say x is equal to plus or minus 1. So that's when the derivative is equal to 0, so those are going to be critical numbers. And then the second place is when my derivative is undefined, and that never happens, so that's not possible. So my relative extrema are going to occur when x is equal to 1 and x is equal to negative 1. Okay, looking at the next one, I'm going to do the same thing. I want to find out when my derivative is equal to 0 or when my derivative is undefined. So the first thing I'm going to do is I am going to take the derivative. Remember, to take the derivative of this, I'm going to actually use the chain rule because I'm taking the derivative of something raised to the 2/3 power. So I'm just going to try and do that. So I'm going to say the derivative is equal to, bring this power down, so this will be negative 2/3 x minus 1. Then reduce that power by 1, so that'll be negative 1/3. And then multiply it by the derivative of what's inside, or my u, which would be 1. So if I rewrite this in a way that I like it, it would be negative 2 over 3 times x minus 1 to the 1/3 power. So that's my derivative. So then I'm going to ask myself, well, when is this derivative equal to 0? That's case number 1. And in order for a rational expression to be equal to 0, remember the numerator has to be equal to 0. So that negative 2 would have to equal 0. Well, that's not going to happen, so I'm not going to get any extrema from there. The second time is when this function is undefined, when this derivative is undefined, and that's going to be when my denominator is equal to 0. So I am going to solve this. So divide both sides by 3, and I get x minus 1 to the 1/3 power is equal to 0. Technically, to get rid of that fractional power, I'm going to raise both sides to the 3rd power, which will be x minus 1 is equal to, well, 0, right? So any power is just 0. So then I'm going to have x minus 1 is equal to 0, add 1 to both sides, and I am going to get x is equal to 1. So my relative extrema is going to be when x is equal to 1, and I should say that a critical number is going to occur when x is equal to 1. And that's the same for this one over here. I said relative extrema, those are also my critical numbers. CN, critical numbers. So a critical number is, and then I just said that, is a number where the derivative is equal to 0, or f of x is not differentiable. In other words, the derivative is undefined. And C is a critical number of f. If f has an extreme relative min or relative max at C, then C is a critical number of f. So a lot's wrapped into those two things. So if I have this function that goes like this here, my derivative is going to equal 0. So my derivative will equal 0. And then this point here is also a critical number. If I tell you that at this point here, you have a critical number, that means that this has to be a relative extrema. So in this case, it would be a relative min. And my derivative would have to equal 0. In this case, it does, or it would have to be undefined. So those are just sort of saying, if one is true, they work both directions, I guess is the best way to say it. So if I ask you to find the critical numbers, find the critical numbers of f in the interval from a to b. The two ways that you're going to find those critical numbers is, one is you're going to take the derivative and you're going to set it equal to 0. The second way is you're going to find out when the derivative is undefined. And usually when it's undefined, that means you have like a denominator, and you can't, the denominator would equal 0. you're going to evaluate f at each of the critical numbers in A and B. So whatever critical numbers you get up here, you're going to find f of those critical numbers. Then you're going to evaluate f at each of the endpoints. So you're going to evaluate at A, you're going to evaluate it at B. The least of these values is the minimum. The greatest of these values is the maximum. So it sounds really complicated, but it's really not that hard. So if I want you to find the absolute extrema of f of x, the 3x to the fourth minus 4x to the third on the interval from -1 to 2. The first thing I'm going to do is I am going to find the two places that I could have critical numbers. So one is when the derivative is equal to 0, and the second critical number could occur if the derivative is undefined, which means I'm going to have to find the derivative. So I'm going to go up here and I'm going to find the derivative f of x. This is the baby one. 4 times 3 is 12. Reduce that power by 1. So I'm going to have 12x to the third minus 3 times 4 is 12. Reduce that power by 1, 12x squared. So when I want to find, that's my derivative. First time is when the derivative is equal to 0. So I'm going to take that 12x to the third minus 12x squared. And I'm going to set that equal to 0. I'm probably going to factor out 12x squared. Make this x minus 1 is equal to 0. So 12x to the third is equal to 0. Divide by 12. That's squared, not to the third. I'm going to get x squared is equal to 0. Take the square root. X is equal to plus or minus 0. That doesn't make sense, so I'm just going to say 0. And here, x minus 1 is equal to 0. Add 1 to both sides. X is equal to 1. So two critical numbers that I have so far are 0 and 1. Then I want to find the places where the derivative is undefined. Well, this is a continuous function. It's never undefined, so there are not going to be any places where it's undefined. So now I have my critical numbers that are 1 and 0. So I have to test 4 points in my function. I have to test these two critical numbers, and I have to test the endpoints of -1 and 2. So now we're going to get out our calculators, and I'm going to show you how to do that on a calculator. So I'm going on a calculator page, and then I'm going to type in the original equation. So I want to find out what's my highest value and what's my lowest value. So the original equation was at 3x to the fourth minus 4x to the third. So I'm going to do 3x to the fourth, minus 4x to the third. And then I'm going to do this such that control equal, get that line right there. And then I want to do, remember, I'm testing the two critical numbers, which are 0 and 1. And I'm also testing -1 and 2. So I'll do 0 and 1 first, and then the intervals. So 0, so x is equal to 0. Get a value. Go up and put in 1. Get a value, put in -1 because that's my first interval, the left bound of my interval, and then I am going to do the other interval, right bound, which is 2. And when I have that, those are my values, so I'm going to just take a screenshot of those and bring those onto my smartboard. So this is what I have. So now I'm looking for my relative extrema. Absolute extrema. So I want to look for the lowest value. And when I look at my answers, I have 0, -1, 7, and 16. So the -1 is going to be my absolute minimum. And then 16 is going to be my absolute maximum. And I got that by evaluating, and that's probably the easiest way to do it, so you're not trying to do numbers. All right, example 4, find the exact absolute extrema on the interval of -1 to 3 of the following equations. So the first thing I'm going to do is find the derivative. So the derivative of 2x is 2 minus, and then 2/3 times 3 would be 2. X subtract 1, so that would be negative 1/3. So I'm probably going to rewrite that as 2 minus 2 over x to the 1/3. So now the first case is when this derivative is equal to 0. So I'm going to take that 2 minus 2 over x to the 1/3, and I'm going to set that equal to 0. And when I do that, I am going to, I think I'm going to add that to both sides. So 2 is equal to 2 over x to the 1/3. To get rid of that denominator, I'm going to multiply both sides by x to the 1/3, x to the 1/3. And when I do that, I'll have 2x to the 1/3. And then here, these will simplify, is equal to 2. Divide both sides by 2, and I get x to the 1/3 is equal to 1. Then I'm going to raise both of them to the 3rd power to get rid of that fractional exponent. And when I do that, I get x is equal to 1. So that's when my derivative is equal to 0. The next case is when my derivative is undefined. And that's going to happen when this denominator is equal to 0. So that x to the 1/3 would equal 0. Raise both of them to the 3rd power to get rid of that fractional exponent. And 0 raised to any power is going to be 0. So my critical numbers, just like before, my critical numbers are going to be 1 and 0. And then I'm also going to test my endpoints negative 1 and 3. So I'm going to pick up my calculator and go do that now. So here there are screenshots from my calculator, and I have 0, negative 1, negative 5, negative 2.24. So the highest number I have is the 0. So that's going to be my absolute max. That's the highest value I have. And then my lowest value is going to be this negative 5. So that's going to be my absolute min. So my absolute max is 0. My absolute min is negative 5. Okay, the next one says locate the absolute extreme of the function over the indicated interval. So they give me the equation, a square root of 4 minus x squared. And in the interval from negative 2, so I want to do the interval from negative 2 to positive 2. So when I look at this interval, I am looking from negative 2 to positive 2. And if I look at this, in that interval, and they're close, so I'm including that negative 2 and I'm including that 2, my absolute minimum is going to be that 0, and my absolute max is going to be the highest value, which is going to be, looks like 2. So, okay, that's fine. So the next one, part B, says I want to do from negative 2 to 0. But see how I don't, so I'm going from negative 2 to 0. So I'm taking this interval, and I'm just looking from here to here. So my absolute max, since I don't include, since it's not including the 0 because of this parenthesis instead of a bracket, I can't include that point right there. So I'm not going to have an absolute max, say none, because I can't include that point because it's not there, and I can't include because it's getting closer and closer to that 2, but it's never really getting to 2. It just doesn't happen. And then, but my absolute min, since I am still including that negative 2, my absolute min is still going to stay that 0. Now the next one, I'm going from negative 2 to negative 2. So I'm still looking at this whole graph again, but I'm not including this point here and this point here because I have these parentheses. So what that's going to mean is I still have that absolute max, which is 2, because that is in the interval, that is the highest point. But when I look at these 2 points here, those were my minimums. But since I'm not including those points, I'm not going to have a minimum. And then finally, I want to do from 1 until 2. So I'm going to erase those X's for a second. And I'm going to do 1 until 2. So I'm going to bring this guy here, and I'm just going to look here. Well, I haven't changed my minimum. My minimum is still going to be, it's still going to be 0 because I'm including that point because it does include that point. But now I need 1. So I need to find this value here because that will be the highest value. So to find that value, I have to do the square root of 4 minus 1 squared. So the square root of 4 minus 1, so the square root of 3. And that is going to be my absolute max. And I guess if you have a burning desire to have a decimal, you could, yes, square root of 3, and that's going to be like 1.7-ish, which makes sense. So I like the square root of 3 for 1.7. And I knew it had to be less than 2, right? Because this was 2. All right. So I guess a quick note is like if you have the brackets, remember that's less than or equal to, greater than or equal to, and that means you include those points. But if you have the parentheses, and we'll switch colors for this, if you have the parentheses, that's just greater than or less than, and that would be an open, so I'm not including. It's close to those points, but not including. So in English, if your max or min, what you think should be a max or min, occurs at one of those places where you have that parenthesis, you can't count it, I guess is the best way to say it. Example 6, how many relative extrema does f of x have based on the graph shown? How would you classify them? Great question. So I'm going to assume, well, I have this point here, which I'm going to call, no, I'm going to call a relative min, but it's also the lowest point on the graph, so I'm also going to call it an absolute min, because that's the lowest point I have. This point here, I'm going to call a relative max. This point here, I'm going to call a relative min, because it's the lowest point in this area. This is the highest point in this area. Lowest point in this area, but it's also the lowest point overall. And since I don't have an interval, I cannot include these points. And they wouldn't be relative anyhow because they're not like changing directions or anything like that. If I'm looking at this, so I have 1, 2, 3. I have 3 relative. I have 1 absolute. Basically, how would you classify them? I did that. And then if I asked you, like what was going on here, when I take the derivative at this point, the derivative of all of these should be 0. All of them. Give an example of a function that would not have a minimum nor a maximum on the interval 2, 9. So I'm doing a graph. I'm going from 2, 9. So I'm going from 2 to 9. And oh, that's really not even close. And I want to have a function that would not have a min or a max. And it's a closed interval, which means the endpoints count. So I think any horizontal line would probably be the best way to do that. So I could draw a horizontal line, and that wouldn't have a min or a max. That would just be whatever that value was. And my derivative of a horizontal line the entire time would be 0. I think that would be what. Now, also, I could think of a graph where, let's say I had an asymptote in there somewhere, and my graph did something funky like this, and like this, and I'm looking from this interval from 2 until 9, and I wouldn't have a relative maximum because the endpoints wouldn't count either. So I think I could have something as long as it had vertical asymptote in here somewhere. That would work too. Just thinking. I like the horizontal line best though, I'm going to be honest. Find the value of a derivative at the extreme of 4, 5. So here is a unique one. So if I gave you a graph that looked like this, and you know, I'll make that my X and my Y, and I gave you a graph that looked like this, and I had this point here, actually let's just make life easy and make a parabola here. And I told you the vertex of this parabola was 4, 5. You would say, oh, well, Mrs. Ward, that derivative is equal to 0. I'll cut and dry. But this one's slightly different because you should recognize this. This looks like it's an absolute value of some sort. It looks like it's the parent function is definitely f of x would be the absolute value of x. So if I asked you to find the, remember, I'm talking about the derivative. So the derivative is the slope of this line. The slope of this line here, since it's going up, the slope would be, looks like the slope would be 1, positive 1. So anywhere on this line, the derivative would equal 1. And then, but here, as soon as I hit this vertex of sorts, as soon as I hit this vertex, I go like this. And if I ask you the slope of this part of the line, well, you would say, Mrs. Ward, that slope is -1. So my derivative will be -1. So what's going to happen is I'm not going to have a chance to hit 0. I'm going to go directly from 1 to -1. So if you think of me graphing the derivative, so this would be the graph of the derivative. I know I'm going into way too much detail, but the graph of the derivative before 4, 1, 2, 3, 4, before 4 would be +1. So it's cruising right along here. I get to that 4, and then all of a sudden it jumps down here to -1. So I'd have like an open circle here and an open circle here. So basically this derivative is undefined. It has to be. It either has 0 or undefined. So this derivative is undefined. And that's going to happen anytime I have what I call a sharp curve. So if I have a point, your derivative is undefined because your slope of that line jumps. In this case, I'm cruising right along and I have a slope of +1, slope of +1. The next thing I know, I hit this vertex and boom, my slope goes down to -1, shoots down to -1. So I'm going to have this jump. So my graph of my derivative is going to be disconnected. So this point here would be undefined, which means my derivative is undefined. And I know that was way more detailed than you wanted, but that's what you get. All right, I hope this helps, and I will see you next time.